very good morning to one and all. On behalf of KLE Society Science and Commerce College Management, Principal Dr. Ghanashyam Giri, and I, Dr. Neelam Pasupate, extend a warm welcome to all in this national webinar on research initiatives at graduate and postgraduate level, organized by Department of Chemistry, KLE Society Science and Commerce College, Kalamboli. It is our privilege to welcome our today's guest speaker, Professor B.M. Bhanage. I also welcome all my dear colleagues, our technical support team, and all our listeners and viewers. Before we proceed with this session, I am requesting our principal sir to say few words and express his views. Over to you, Giri sir.
Good morning, today's speaker, Dr. Bhanage sir, all participants. This topic is very much essential in this particular period as all students are to be research oriented in coming years. There will be no future if one is not research oriented. One has to be innovative. There will be market for ideas in coming years. So one has to develop new ideas, and it will be possible only when you are research oriented. On behalf of our chairman, Dr. Prabhakar Kore, our governing body chairman, Dr. Kavadgimat sir, I congratulate the chemistry department under the leadership of Richa Singh madam, who has conducted this particular webinar, and I am sure that our today's eminent speaker, Dr. Bhanage sir, he will throw light on the different avenues available in the field of research, especially for chemistry, for our graduate and postgraduate students. Bhanage sir is very well associated with our KLE society for a longer period, and sir always guide us in different arena of the development of science fraternity. So once again, I welcome all of you on behalf of KLE Management and KLE College of Science and Commerce, Kalamboli. Thank you very much.
Thank you so much, sir. Your words are inspiration for us, sir. And now, as we all belong to science field, and especially being a chemistry person, we all heard his name, that is Professor B.M. Bhanage. But to know more about his work and his contribution in the field of chemistry, I will request our head of the chemistry department, respected Dr. Richa Singh madam, to introduce today's guest speaker. Over to you, Richa ma'am.
Am I audible? Am I audible?
Yes, ma'am. Please continue.
Okay. Thank you, Neelam ma'am, for giving me this opportunity. First of all, good morning to all of you. I am highly delighted to introduce you all with our today's speaker, Professor Bhalachandra M. Bhanage. Professor Bhanage obtained doctoral degree from National Chemical Laboratory in 1995 and spent 7 years in Tohoku University and Hokkaido University, Japan, on various positions. He joined Institute of Chemical Technology as a professor of industrial chemistry in 2003. During 2009 to 2015, he was head of the Department of Chemistry, and currently he is Dean of Infrastructure and Campus Development at ICT. Professor Bhanage has contributed his work on catalysis for activation of small molecules like carbon dioxide, carbon monoxide, and hydrogen for various reactions. He has developed novel strategies for various reactions like Heck, Suzuki, Sonogashira, coupling reactions, their carbonylative forms, hydroformylations, and aminocarbonylative, alkoxycarbonylations, aminations, hydrogenations, etc. His work is focused on developing strategies for catalyst products, separation and catalyst recycles. He has developed several homogeneous transition metal based catalysis for these reactions and solid base catalyst for carbon dioxide fixation reactions. He is also active researcher in the field of nanoparticle synthesis and its catalytic applications, enzymatic catalysis, etc. He has published more than 410 research papers in he has guided 45 doctoral research. This is a brief introduction of this academic. Hope I have done justice in introducing our today's speaker. My apologies if I have made some mistake in his introduction. Now, would request Professor Bhalachandra M. Bhanage sir to take over the session. Bhanage sir?
Yeah, so first of all, I'm thankful to KLE institutions for inviting me to deliver talk on this something off topic, because normally people talk about research topics, some related research, but this topic is really important because research initiatives will be very important if you want to stand in long run. So I'm thankful to organizers for inviting me. As we have seen that recently Government of India has started NIRF ranking, and we have seen many institutions are coming up in this ranking with good ranking numbers. And if you look for why they got such higher ranking, you will see that they have very strong research base. So it also means that if you want to develop quality, you must focus on research. And exactly that is my today's topic. So let me go ahead with my presentation. As far as our country is concerned, we have very good attractive investment destination for technology transactions in the world. Can you hear me clearly? Okay. So we have strong
Your voice.
science and technology, and if you want to keep our growth rate, we must develop good manpower in science and technology. Then and then only we can develop manpower which can adapt the technology, develop the new technology, and therefore we must change our focus on how we are teaching science subject at different colleges. If you consider our standing, we are topmost country in the world in the field of scientific research, positioned as one of the top 5 nations in the field of space exploration. We know that we have very good space missions and many achievements which we have, and we are certainly proud of all these achievements. And this is possible because we have very strong manpower which is there in the science field. One minute, what happened? Now, if you consider our statistics for research, we are ranking 10th for patents, which is very important. But if you look for these patent numbers, most of them are filed by the foreign multinationals. So we are lacking for patents, but as far as scientific publications are concerned, we are at 6th position. And for many journal houses, particularly for chemistry, if you look for SCS and RSC, we have already overtaken many developed nations. So as far as statistics is concerned, it's really good. We can see that the number of increase in the publication every year is by around 1,000. And if you consider the Nature Index, India ranks 13th position in 2017. But consider our population. And considering our population, we have just 216 researchers per million population in 2015, and yet that number is not changed much even today. So we have improved our rank in the Global Innovation Index for the second year consecutively, from being ranked from 81st position in 2015 to 66th position in 2016 and to 16th in 2017. So Government of India is extensively promoting research parks, technology business incubators, then which can promote innovative ideas till they become commercial ventures. India is world's third largest technology startup hub with incorporation of more than 1,000 new companies in 2017. Engineering R&D and product development market in India is forecasted to grow at CAGR of 20.55% to reach $45 billion by 2020 and $28 billion in 2018. So this we have almost achieved. Our statistics is really impressive. But look at this number. We have just 260 researchers per million population. Now, Government of India has started a scheme of Prime Minister Research Fellows, PMRF scheme. This promotes mission of development through innovation at a total cost of 1,650 crore for the period of 7 years beginning from 2018 to 19. And government has announced grant of rupees 1,000 crore for the second phase impacting research, innovation and technology. This scheme is known as Imprint scheme. And you can get more detail on the government's DST site and HRD site also. This imprint scheme will allow you to develop innovative ideas and you can get funding through that. Also, they have started Atal Innovation Mission with $24.84 million to boost academicians, entrepreneurs, researchers to work towards innovation. So point is, when you look at all these things, you will observe one thing. Government is not focusing on just publishing the papers. They want that you do the research and take it to the society. And all these schemes are related to that. So you develop something, join hands with the technocrats, and you can commercialize your innovation and to reach the masses or society. That is the objective of government. In earlier days, researchers used to publish. Of course, that is also important. Publication is also important. But also researchers should think how their research can go to the society. And all these initiatives are in that direction and they are welcomed by many institutions. Now, DST budget is increased by just 4%. If you consider, that is not sufficient as of today. That is my opinion, because we need more funding for research and we need to see that research funding should improve. Same way, Department of Atomic Energy has also allotted 16,000 crore rupees with increase of 19.71% against previous budget. Ministry of Earth Sciences has also allocated around 1,901 crore with increase of 5.65%. So when you consider percent-wise increase in this budget, that is not much, and considering the country size, we need to invest more for our science scheme. There are many schemes which government has sanctioned during last 4 years, and one of the popular scheme is CSIR Junior Research Fellowship. Very tough, competitive to get JRF to CSIR examination, what we called it as a NET. Fellowships are limited to around 10,000 number, including all the subjects. There is also one scheme by CSIR. If you are working for 2 years and publish some research in reputed journal, you can directly get senior research fellowship. So this scheme is also there. There are some more schemes like Shyama Prasad Mukherjee Fellowship, CSIR JRF GATE Fellowship for engineering and pharmaceutical sciences students, CSIR Research Associate those who have completed PhD and they want to do postdoctoral research, CSIR research associate schemes are also there. Then CSIR also has senior research associateships, and CSIR also has Nehru Science postdoctoral research fellowship. So all these schemes details how to apply and all other details you can find it on CSIR HRDG's website. Now, India is aggressively working towards establishing itself as a leader in industrialization and technological development. That's what I said. Government has changed its focus from just publishing house to publish as well as take the technology to the market. And we have seen that significant development has already taken place in nuclear energy, space, and many other fields. Nanotechnology is expected to transform the Indian pharmaceutical industry because nano drug delivery is one of the important topics. Agricultural sector is also likely to undergo major revamp with the government investing heavily for technology-driven green revolution. Government of India through science and technology and innovation policy aspires to position India among the world's top 5 scientific power. Indian Space Research Organization ISRO launched its first human mission by 2022. Now, as I mentioned to you, let us statistically compare our figure at international level. We have just 140 researchers per 1 million population as compared to 4,651 in US. China has invested about 4 times more than India, while United States invested about 75 times more than India on science and technology. Highest ranked Indian university for engineering and technology in 2014 was IIT Bombay at a number of 16. Natural sciences ranks were lower. While India has increased output of scientific papers fourfold between 2000 to 2015, overtaking Russia and France in absolute number, this is very important. We are not producing quality research. That is another concern. And rate has now exceeded by China and Brazil. Indian papers generate fewer sites. Because if you publish some paper, how many researchers follow and how many citations it gets, that tells you the importance of your work. So citation for your publication is very, very important. And India is lagging behind in the citation of this paper. So we need to improve the quality of our research. And if you consider there are various institutions in India who are looking after the development of science. For example, science academies. Idea of science academies in India was evolved through Indian independence movement, and we have 3 science academies, that is Indian National Science Academy, Indian Academy of Sciences, and National Academy of Sciences India. They are all found pre-independence era. And Indian Academy of Sciences referred as Bangalore Academy, founded in 1934 by Nobel laureate Professor C.V. Raman. Then National Academy of Sciences is located at Allahabad, and Indian National Science Academy, popularly also known as INSA, and this is also one of the prestigious academy. They do a lot of things for popularization of science. I will come to our topic, that is research for undergraduate and all that, once I complete all these statistics. So we can see that no growth for enrollment in post-school education between 1900 to 1947. Gross higher education enrollment ratio was 11.5, global average is 26%. We need more universities. Number of universities in India should have been at par with the country. For example, if you look for population in million and number of university, Korea 45 million population, 120 university. UK 50, 170. India population, and you can see just 440 universities. So we need to expand number of universities in India so that we can attract more manpower towards science. Currently, we had expanded, for example, in last decade, we have started 30 central universities, 5 institutes of science and education research, that is ICERs. This is very popular model, and really they did excellent job as far as quality of research is concerned. And the concept was they want to develop institute similar to the India's top institute, that is Institute of Science. And it is a replica of Institute of Science, and they are renamed as Indian Institute of Science, Education and Research. Here, today's topic objective is served, that is, involve undergraduate and postgraduate in research and develop them. So, with this mission, government started this institution. Then 8 Indian Institute of Technology, that is IITs, 7 IIMs, 20 III, triple IT, 1,600 polytechnics, more than 10,000 vocational schools, 50,000 skill development centers. So we are expanding, but it is not sufficient as far as population is concerned, and that is the reason we have cutthroat competition for the marks. And to get into this institution, we have seen the kind of competition is going on because these numbers are not sufficient for our population. Corporates are also involved in the research. For example, our pharmaceutical industry has done excellent research in pharmaceutical sciences, drug development, copying the molecules to creating new molecules. MNC R&D centers are there in India. They are also doing a lot of research. And we have seen that we have around 780 MNC R&D centers in India. 281 of 1,000 mega R&D spenders are centers in India. 160,000 scientists work at MNC R&D center. So this is also a place wherein we can have a lot of research activities going on. Now, as I said, if picture is so rosy, why I'm talking about the undergraduate research and postgraduate research? We have seen that these are islands of the excellence like IITs and ICER. And if you consider India's population, how much percentage of population they serve? Maybe below 1%. So masses are deprived of the research, and that is also another concern. And reasons for the decline of quality of research in India, when we are learning our undergraduate syllabus, we have lots of things there wherein experimentation can be planned. For example, if I am doing the coupling reaction and I'm learning the coupling reaction in organic synthesis, why not giving the experiment on coupling reaction? We are still doing the old generation experiments like spotting, detection of the group. These are all phased out all over the world. Today, all over the world, you will find the experimentation is mostly with the instruments. And unfortunately, in many places, you don't find instrumentation with the instruments. Yes? So, our education has maintained status quo for many decades and with minor reforms. As far as I'm talking about university research concern, I'm not talking about the elite institutes. They are constantly reforming, evolving, and therefore they are getting their rankings also. I'm talking about the state university run the system. So how they can evolve. And therefore we need to focus there because masses learns all the science there. And if we get the manpower, we may not get the best possible manpower because most of the cream goes to the IITs, ICERs. But whatever students comes here, if they train properly, they are also useful scientists or technocrats or technicians, whatever role they can play in the industry, that is possible. And therefore, we must focus on improving the research at college level and particularly undergraduate level and postgraduate level. And that's what I say, the syllabus we have not changed because it's with the minor reforms. There is a segregation of teaching and research in the countries. For example, most of the colleges, I'm not calling all, because some colleges had taken a lot of good initiatives, they have developed their research. I'm not talking about all, but most of the colleges are just focused on the teaching and they are not giving emphasis on practical education. And that is a concern today. And therefore, we must think on this particular aspect. Our graduates lack skills required for the employable as well as knowledge in the industry. For example, if BSc analytical chemistry students comes out and he has not handled the GC, HPLC, IR, UV, what type of practical knowledge he has when he goes to the industry? And unfortunately, in many institutions, we don't find these instruments are there. Unless and until they practically handle such type of instruments, they are not expensive also. Let me tell you, many times we feel that it needs money. For example, palladium catalyzed coupling reaction. How much palladium you need? Just few milligram. Your solvent cost may be more than the palladium cost. GC, HPLC. Many indigenous GCs and HPLCs are available at much cheaper rate, and that will also give the indigenization effect for development of instrumentation in the country. And we should become independent on the manufacture of instruments. Unless and until there is a demand for these instruments, manufacturers will not come out, and hence we are buying the foreign equipments, and which leads to the very high cost of these equipments. And we have seen that there were many manufacturers in country earlier, but they were taken over by the MNCs because they want to retain their business. So point is, our undergraduate research should focus on the experimental part. We have clear-cut boundary between UG, PG, and doctoral research. In fact, that should be gone. If PG students interacts with UG students, the interaction is much better than the teacher interacts with the UG student because age gap is less. So when practicals are going on, and if PhD students are teaching PG students, they transfer their skills very efficiently. And if you look for the abroad, particularly in countries like Japan, Germany, China, many countries, you will find there is a professor, his group, and his group will have UG, PG, doctoral, all students, all of them are working together and doing the experiments together. And this leads to hierarchical approach in which doctoral students will take care of PG students will take care of UG students, and developing the good research environment and culture. And this particularly lacking in India because we have clear-cut demarcation in this particular discipline. So we need to think over this and how we can minimize this demarcation. That is also another question. Plenty of UG manpower is available, and on other hand, you will find many institutes in country are looking for young and bright manpower. They have equipment, they have infrastructure, but they are just sitting idle because there is no manpower. So there should be some synergy between available manpower and where there is a need of manpower. So particularly management of our manpower in science area is lacking. You can see that as in many institutes, particularly central government research institutions, they have scientist system, but they don't have somebody who will work under the scientist. And scientists are willing to guide the students. And if such UG students are available with them, they can help and they can also do the research. In that direction, I can say that there were two initiatives, but they are not at large scale. One is by the Homi Bhabha Science Center, which is located at Chembur, Manpur. So they have started National Initiative for Undergraduate Research. What they did, chemistry Olympiad and all Olympiad students were asked to do the research with the top institutions like KIFR, BARC, ICT, IIT, and these students used to do research after 12th. And many students were successfully completed their research projects, published their papers, and important point is at this age they got the skills to do the research. That is important. They may not become researcher, but if they get the skills to do research, that is what is required. And therefore, this last point, that is manpower availability and shortage of manpower, we need to see and we need to bridge this gap. And if you look for the university college system, one of the causes of problems plaguing higher education in India is that system affiliation system, wherein university can have just affiliation. For example, many universities have more than 500 colleges, and this simply becomes university ungovernable because they cannot focus on research. They are becoming examination taking bodies. And we need to think over this point because universities are not meant for just taking the examination. They are supposed to do research. And therefore, besides being logistical and administrative nightmare to the parent university, these colleges function in isolation and there is no real communication amongst the academic disciplines. It defeats the one of the fundamental principles of a university of being an institution where students and teachers are able to exchange idea and different disciplines mingle. In the process, learning from one another and finding ways to innovate. And within university also you will find there is a minimum interaction between the departments and there is a lack of interdisciplinary education and research on the university campus. And that these are also some of the reasons why there's a decline in the quality in university system. If we know this problem, but if we can overcome these problems, that will solve many things. Because BCUD, for example, university BCUD gives good funding to the college to do research. And currently, Mumbai University has taken good initiative to increase the funding for research. And I think in long run, definitely it will help them because this BCUD things can be definitely helpful to the colleges to start preliminary research at college level. My concern there is there should be some more interaction with the university departments and colleges. And university departments should become mentor to the colleges to develop their research. Now, when you consider the way forward, college and university can form a center for undergraduate research. This is another way. Because sometimes colleges may not afford high-end equipment. For example, if you are working in the nanotechnology, you need FEG, SAM, SAM, TEM, XRD, TGA, DSC, so many high-end characterization equipment. No college will afford that. And so does it mean that nanotechnology research should not be done by the colleges? No. Answer is no. There is a one way out. University college can come together and they can form conglomerate and develop special instrumentation center. And through BCUD type of projects, by payment basis, small payment basis, these centers can serve as a analytical development centers wherein the need of the researchers can be taken care. And therefore, this will give a lot of load on the colleges for maintaining high-end equipment. This can be also a good concept because this is also applied in many universities all over the world and it is successfully implemented. So this can be a good problem. So we can solve that. Then faculty members can assign problems related to syllabus. I have seen that in today's colleges, we have find many good quality faculty members. Many of them have done the postdoctoral fellowships at somewhere abroad, and they want to do something, but suitable infra is not there. For the research, three things are very important. One is freedom to do research. Second one is quality manpower, and third one is money to do that research. So, if we provide that environment to the faculty member and ask them to do the research using these concepts, whatever concepts he has, and he should develop problem related to syllabus. I will show you one example for this type of argument. And as I said, university resources can be used to fund such research in terms of infrastructure and faculty. Research problem can be designed based on available resources. One part, sometimes you may not have resources, fine. You may not have resource to do research, fine. But whatever something available at UG level also you can do. For example, multi-component reactions. Doesn't need much. You need glassware, that's all. And the chemicals, normally most of these chemicals are inexpensive. And you can do very easily multi-component reaction on the limited resource. So based on available resources, this is another technique by which you can do the research. And therefore, I said that research environment like faculty, postdoctoral students, doctoral students, postgraduate students, graduate students. Such tree is necessary everywhere to have quality research. As I mentioned, research many people get confused what type of problem they should select. If you select problems which society is facing, that will get utmost attention. Government will also fund it. For example, now COVID, although it created lots of problems, but also it also gives your brain to think and how to overcome all these problems, to develop the new drug molecules or to develop new PPE kits or to develop novel type of sanitization techniques. So many things one can think. And such point of research is also very, very important. UG student can come out with many, many bright ideas. Detection of COVID toolkit, so many things is possible. So therefore, if you select research topic relevant to societal importance, because for research, publication should not be the only criteria. If your research goes to the society or industry, that is also a successful research. Our judgment of research by just publishing in the publication is wrong, and that mindset we have to change. Faculty should involve UG students. For example, suppose some faculty members are writing review articles. UG students are best source to source the literature. And once UG student source the literature with the help of UG students, faculty members can write excellent review articles. This will develop writing skills to the UG students, and this is also very important because our students should not be developed just because of the technician or like that. There should be good writers, they should be good orators, they should be good communicators. All aspects of the student should be developed when he was doing the undergraduate research. And such type of activity, although it looks something different, mundane, but it needs and that develops these skills in the faculty members. And that's why I said develop communication skills, writing skills, identification of problem. You will find many, even PhD students are not able to write a simple application letter for a leave. You ask them. Many PhD students don't know what is the full form of PhD. It's a sad story, but I have observed such type of thing. And therefore, as a faculty member, our role to develop students in all possible ways. And as I mentioned, research topic should be of societal importance. If you don't find that, if you are interested, you develop research topic related to syllabus, their learning, and this topic should be multidisciplinary in nature. I will give you one case study. There may be many case studies like this. For example, analysis of wastewater. It's a good topic for any analytical chemistry student. So topic can be given to undergraduate student. He can collect wastewater in the nearby sources. Now, to solve this problem, you need chemistry knowledge, environmental sciences knowledge, biotechnology knowledge, because you may look for BOD, COD analysis or type of species present in your wastewater. So many multidisciplinary things can be given. So suppose you are giving wastewater treatment here, this project can be taken by chemistry department with respect to chemistry component, environmental sciences department with health component, biotechnology with biotechnology component. Remember, this creates local data for wastewater. And generation of local data is also very, very important. Who will generate local data for India? Finally, we have to create the data. It may be the environmental parameter, it may be the water parameter, it may be the groundwater analysis. So all local data we have to generate, and UG students can do such type of research very effective. Sometimes it may involve material synthesis and characterization. So for example, if you are treating wastewater, you may use nanomaterials. You need high-end equipment. Fine, you develop nanomaterial, and as I mentioned earlier, how high-end equipment can be used, you use them. And such type of case study I have given, there are many problems this way you can take up and develop research around UG students, and of course, if you want PG students. Now, sometimes it's fine that we can do this, and how to get money, that is very, very important for research. And that's why we have to write research proposal. So once I will give you some background about how to write research proposal, because that is also very, very important. Once you decide that you want to develop research proposals, and you want to develop undergraduate, postgraduates in research, you need money to develop those. So I'll tell you something about how to write research proposal. First of all, you should know the funding agency. National level funding agencies are UGC. You can go to the UGC website, you will find the research proposal. If you are engineering institution, you can go to the AICTE website, you will find the research schemes. There are many research schemes available with these bodies. And not only for the individual faculty members, but they are available at institutional level also. So research promotion scheme, then industry institution interaction schemes are there by AICTE. You can find lots of schemes available in AICTE website. And if you want to know more detail, go to the AICTE website, you find all the details. CSIR is another good body which supports lots of things. For example, they support research schemes. Then they also give sponsored research scheme for retired scientists. They give emeritus scientist scheme, research fellowships I had mentioned to you earlier, and many science tech and technology programs are run by the CSIR. All these funding agencies also support if you want to attend some conference, and they support your registration and travel cost if you apply well before you start your journey. And CSIR you can be contacted. Same way, DRDO, defense related, if you have interest in doing defense related research, they also have good funding schemes. You can look for their website and you can write the proposals there. Same way with DAE, they have good fellowships, Raja Ramanna Fellowship, K.S. Krishnan Fellowship, DAE Young Scientist Research Award. So many schemes are available with Department of Atomic Energy. And refer to the website of all these schemes and you will get the details. DBT also gives good scheme. For example, chemistry person do a lot of things with the biotechnology, because finally enzymes and all those things, if you need characterization, you need chemist. And therefore, DBT also supports a lot of things with respect, besides biotechnology, chemistry related research. One can refer to the different schemes available with the DBT. Same way, Department of Coal, and very important body as far as funding is concerned, that is Department of Science and Technology, that is DST. DST is a parent body, gives funding for the research, and they have many schemes for the research. You can go to the DST website, you will find plenty of schemes are there. Then there are many ministries, Government of India ministries. They also have their own funding mechanisms on their website. You should surf and find out which is the most suitable scheme for your research, and accordingly you should apply. You can see INSA. Now, one can also apply for international funding agency. So, TWAS, then International Foundation for Science, so many things. SCRB has started a new scheme for funding of high risk, high award research. Suppose you have some kite flying idea, you can go to the SCRB website. You will find funding for high risk, high award research. You can also think to submit your research proposal there. So you have to decide at which level you want to write research proposal. One is global, followed by national, followed by state, followed by institutional, followed by university level, and depending on where you would like to write, you can write research proposal. Now, sometimes grants and fellowships are also available. Grants are normally submitted by the institution on the behalf of PI. Funded to the institutions, indirect cost apply, final report is required. Fellowships are given to the individual. Any proposal when you write, it goes through different steps. For example, PI or institute writes the proposal, it goes to the central processing. Program manager looks into this. If required, they will do the site review, or they can do ad hoc mail reviews. Then panel will decide what to do. Based on the panel's decision, division director will either award or decline or ask to withdraw. And once it is awarded, you have to start your research project. Now, in government, typically, if you want to write your proposal, regular faculty members are encouraged. Some senior administrators are encouraged. Students are given in exception to serve as co-PI on dissertation research. So when you want to write good proposal, you should have good idea. Research addresses significant problem. Clear description of research activities is important, and it should fit with funding agency's priority. For example, if you are asking to DAE, you should write something which is interesting to DAE. Otherwise, they will not look into your research proposal. Therefore, agency's priorities you have to decide. Factors which you cannot control, that internal politics within the funding agency, stiff competition from other applicants, and that's the reason why I suggest faculty members, those who have good CV, they can directly go. Those who don't have good CV need not be discouraged, because they can develop their CVs through, once you start, take initiative to do some research, start publishing some papers, develop some good CV, and then you start writing the proposal. Directly don't jump into writing the proposal. Otherwise, normally PI's credentials are considered while awarding the research proposal, and therefore PI's credentials are very, very important if you consider the outcome of your research proposal. The quality of your own proposal you have to decide. So I will tell you how to write. Once you write your proposal, you consult that proposal with others and let it get discussed and debated in some good body. And once you come to know the lacuna in your proposal, you can remove those lacuna, make it perfect, and then you can consider. So typical proposal, any funding agency if you look for, it needs title, referees, applicants, budget, other operating costs, non-scientific abstracts, summary of research, details of research proposal, how you will implement this proposal, national and international status of the research which you have proposed, timeline and milestones when you will execute this project, and applicant CV. All these things matter. So you should have good title, which indicates the typical research proposal. For example, if you put too long and technical title, it will not gain reviewers' attention. Too short or broad title will also affect the critical critical of the grant. So you should write proper title. It should not be very big or it should not be very small. It should describe the research proposal which you are writing. Referees, you should choose good referees in your field of research. Choose good scientific and colleagues that will objective but not too critical of the science. So while selecting referees, don't select or choose your collaborators, because anyone can very easily find out your referees are collaborator or not. And if you write collaborator as a referee, that will go negative to your proposal. Do not choose competitor in your field because they have some different views. Do not choose top scientist in your field because they may not respond or they may not find time or they may be too critical. So choice of referees is also important. You should select good co-applicants. That is also important. So some junior investigators should join you as a co-applicant. Co-applicants should give good backup to his skills and your research proposals. Budget, it's very important. For example, if you are writing your proposal for university budget, you know that they typically grant 1 lakh, 10 lakh. But if you write 1 crore proposal there, it will be straightway rejected, because what will happen, each funding agency has decided some parameters. So once you decide to apply for some scheme, find out from your colleagues what is a typical budget they offer, and accordingly you write your project proposal. So budget is very, very important. Declare all operating costs, declare 0 to 100% overlap. Do not state 20 to 50% overlap with other projects. Consumable, contingency, wages and fellowships, analytics, expenditure, all these details you should give when you are writing the proposal. So these are recurring expenses because you need it over the period of, say, typical 36-month project proposal. You need all these things, and there is a typical funding available under each heading, and you should be aware about what type of funding they give under each heading. And when you look for non-recurring expenditure expenses, suppose you need some good equipment to do your research, you can put it as a non-recurring expenditure. Many people don't understand what is meant by recurring and non-recurring. So all these terminologies you should learn, and you should get the acquaintance with these terms. You may need travel expenses, so you can also mention your travel expenses. Overheads, institute takes typical overheads charges for your project, so that also you have to mention. You can mention timeline and milestones for your project. I have given here some timeline. So literature, survey, purchase of equipment, searching the synthesis and characterization of novel catalytic system. So such timelines can be given in a proper way. Non-scientific summary should be good, and it should avoid acronyms, clearly stated. Layman should able to understand the non-scientific summary. Summary of research proposal also should be same, should be in a simple one. And you have seen that order of research proposal is very, very important. Point is rational, why you are doing this research project, what is hypothesis, what approach you will adapt, what are your expected results, and what type of pitfalls you anticipate, and if there are some pitfalls, what type of alternative approaches which we have envisaged that you have to consider while writing the specific aims. So this should be the order of your proposal: goal, background, rationale, specific aims, significance, and goals. As I mentioned just now, so details of research proposal I had also mentioned. I will skip some part here. Now, when you write your research proposal, you should be clever enough to hide the typical part of your research proposal. Anyone should not able to reproduce it, because someone else may take it up and publish it, and you will just. So while writing research proposal, you should be writing in such a way that while you are writing your patent, explaining all the scientific background, but not clearly what I say, telling the details about the proposal. And therefore, this is very important. Applicant CV is very, very important. And I have seen many places very good CV are there with many teachers. They can definitely consider to write a research proposal. And if you don't have CV, you start research and then you will come to know. So general thought, reviewers will not be experts in your field when they are evaluating your research proposal. So research proposal make accessible to them. Get your research proposal read by your colleagues or someone in area to research. They might find problems that reviewer will find. So summary for good research proposal is: start with good idea. It's carefully researched, matches a particular sponsor's priorities. It is neat, well written, follows the guideline carefully, describes the need for research, objectives, plan of operation, expected outcome, evaluation plan, sustainability and timeline, and demonstrate cost effectiveness. Sometime it may happen resubmit, you can submit based on the comment. Then once your research proposal is accepted, they may call you for the presentation, and you have to present it in a proper way to the funding agency system. So point is, as I mentioned, whether research should be done by the undergraduate and postgraduate student. Yes, it's a need of our, because if our UG students start doing research, they will be developed for their future. So undergraduate students should involve in research activities, and they must be related to their syllabus. And then only we are producing industry ready graduates. And I had given you earlier one example also. Analytical chemistry, who has not handled a single instrument, how he can run the analytical chemistry lab in the industry? Or analytical chemistry, once he has done the practical, suppose for example GC, he is doing GC, and if he has handled the GC, he know how two peaks can be separated, what parameters he should play so that peaks get separated. So something like that, sports should be played on the ground. should not be played in the classroom. Is something like that. So therefore, if our undergraduate students have hands-on experience, it may not be precisely high-end research, but it should involve some component wherein they are involving high-end equipment. Need to develop suitable ecosystem. Resources can be sourced wherever available. That is the skill of individual faculty member or institute can provide to their colleagues. Research can be also planned with available resources. I had mentioned to you, even if you don't have, as a chemist, India's chemistry background is very good because even if they have just glassware, many people have published a lot of research because glassware is what is required. And what you need afterwards, NMR, taking NMR and establishing the structure. So with limited resources also you can do the research. But if it is supported by high-end equipment, this will lead to the very good quality research. That's why I am concerned about how it can be lead to the higher level. Everyone should do research is a bad idea because we are experienced in previous pay commission, everyone started doing the research. And there were the mushrooming journals. Everywhere you will find anyone is starting international journal of something and publishing. And whether it was really required, because most of the things are just minor changes with the existing literature. Journals were not having proper impact factor. You should know the quality, the journal where you publish. You should publish in a quality publishing house. For example, society journals like RSC, SES, Wiley, or Elsevier, Springer, Taylor and Francis. Such reputed publishing house you should publish. Otherwise, work will not be noticed by the broad audience and it will not get noticed also, even it may be having good quality. Then impact factor of journal is also very, very important. You should strive for the getting very high impact factor journal publication. And therefore, if you feel that you are not a research person, don't enter into this territory because it's not everyone's cup of tea. But if you feel, if you want to do something, there are many ways. Some people will guide you. You have to find mentor who can guide you and you can do the research. And I think government has rectified the mistake which they did earlier by everyone should do the research and mark. So now that is rectified. We have seen this in past, as I mentioned. Research experience in teaching is always useful for teachers, also for students, because when teacher who have done some research and when he is teaching in a classroom, definitely it makes some different impact than teacher who has not done anything and just teaching the syllabus, whatever they were available in the text. There is a huge difference between the quality of teachers, those who have done actual something on the ground and then teaching. And therefore, my advice is always that for teachers, whenever they get some summer fellowship or some INSA summer fellowship, they can apply, they can go to the top level institutions, they can learn the research technique and then they come back to the college and that will be useful in their teaching improvement because academies are doing good job with respect to teaching the teachers through academic fellowship, summer research fellowship for teachers. Same way they are also doing summer research fellowship for students and you can ask your students to apply for the academic. And therefore I said that teachers should think how he can involve in the research. And many countries you will find that researchers or teachers goes to the industry and they come back to the original teaching position. Particularly, it's very common in Germany that many teachers goes to the industry, spend some time there, and they come back to the teaching profession, and that makes tremendous impact. And we have seen that the quality of research they are going on, and therefore we should also introduce such type of schemes wherein teacher can spend some time, particularly summer vacation, in some good quality industry and come back and make use of his industrial experience while teaching, and that can certainly help the students because in future teaching will be completely different way because today students are smart, they have complete access to the knowledge, but teacher's role is very important. It will not go because having access to the knowledge is not important. which is the correct knowledge, and their teacher can guide the students. This is correct knowledge. Lot of literature is available, but don't look at this. This is the right things which you should learn, and but for that purpose, teacher also should know which should things they should take, and therefore research experience counts there. And therefore, I say that if teacher is not having research experience, he should develop research experience, and that will definitely he can himself can judge that it has changed the picture as far as teaching is concerned. So finally, I would like to thank you for your kind attention. I will be happy to answer your questions if you have any.
Thank you so much, sir. Thoroughly, you explained each and everything regarded to research, sir. And as usual, your all the things are with the proper depth, and you are explaining it very well, sir. Thanks a lot. And many of our students are also want to go with the research, but because of lacking of knowledge of platform and fundings available, they are not actually thinking about the research. So your this session will be really helpful, not only for students, for us also. We can think about it. And the good thing is, sir, in last month only, with the help of my guide, you know him, Prakash sir, PDV sir. So I dropped one paper in the publication also. So it is really good to have a research and teaching simultaneously in a parallel way. So with this session is definitely will be helpful for us and for student as well. And one good thing is this session is available on YouTube platform. So whenever anyone want to watch this, they can go and watch this. So for the question and answer session, I will request our Professor Mr. Yogesh Nani sir to continue with it. Over to you, Yogesh sir.
Am I audible?
Yes.
Good afternoon, everyone. No, there are few questions, but before asking no questions, I want to share one moment of Bhanage sir that we have spent with him during Nehru Science Center. I have got that opportunity that no 10 students from our 11th standard, that is junior college. I have taken them to Nehru Science Center for fascinating chemistry. There was no one talk of Bhanage sir on fascinating chemistry, and Bhanage sir students were guiding our students. Now, how to learn by doing. So that was very nice session, and our students were very much inspired by that your session, sir. So, sir is inspiring no young minds for different types of research. How should we research carried out? So, thank you very much, sir, for that. So now I will start with the questions. So very first question is asked by Raju Sapresa. Actually, he has asked two questions. That do you think interdisciplinary research must be inculcated among UG and PG students? What can be done in this direction? Over to you,
Yeah.
sir.
Yeah. As I mentioned, interdisciplinary research in UG and PG, what happens? The gap between UG and PG student, age gap, is very small. So they convey, UG students are, PG students are more mature, and they can easily convey the experimental techniques to the UG students in a proper way. Now, as far as interdisciplinary aspect is concerned, for example, suppose I had given one case study of wastewater analysis, and suppose UG student is bringing some wastewater sample, and PG student is well trained in analyzing them on the GC or HPLC, so he can teach that very effectively to the UG student. That is not possible by teacher or some guide or some. So that's why I said this is the ecosystem. Everywhere you will observe in the world, UG, PG, postgraduate, then doctorate and postdoctorate.
Okay, sir. Now, next question is being asked by Rajesh Sapresa is that research methodology should be inculcated in no syllabus of UG students. So small research project can be included in their syllabus. What do you think, sir?
Research methodology is already a subject in many PG syllabus, but not in UG syllabus. So I don't think that syllabus is required at UG level, but UG student, if they come to know what type of research literature search they can do, or how they can search the literature, how they can define the problem by their own mentors in the PG, that will be really useful.
Okay, thank you, sir. Now I'll request Dr. Kumudini Lokhande to ask remaining question. Thank you. Over to you, Dr. Kumudini Lokhande.
Good afternoon, sir.
Good
Sir,
afternoon.
I have few questions with me. The first
Okay.
question is from Runal Vandare.
Mhm.
She has asked, most of the universities in India emphasize on theoretical learning rather than the practical one. So can you just highlight how to change from this theoretical to practical learning?
Exactly, that was my concern. If you look for my talk, it was focused on how we can become more practical learner. We should move away from the textbook knowledge to the practical learner. And we need to change a lot in that direction. Because universities should invest more on developing the practical infrastructure. For example, they should invest more on the instrumentation part, they should invest more on the research component related part rather than just conventional teaching.
Right. Sir, the next question is from Subhadra NR Bhagat Senior College. And he asked that in non-granted college, whether teachers want to try to undertake some research projects, then how do we approach to DST or SERP? Like, what is the protocol to be followed then in that case? Because they are non-granted college teachers.
Non-granted colleges, normally these funding agencies don't offer support, but universities can support to some extent. So university BCUD you can approach, and through BCUD you can get some funding. Another way is you can associate with some colleagues in your granted college and you can jointly submit a research proposal. This can be another way.
Right.
Next
Sir, the
point.
next question.
One more point in this particular part. You need not always look for government for the research funding. Suppose you have some practical problem which can be solved by the industry, required for the industry. You can directly approach industry. They don't look into the whether your college is granted or non-granted. Industry can support such type of research project if it is applicable to or interest to them.
Right. So the next question is that from Santosh Kataria, they are asking you, have you handled such a small project which you have conducted in your UG or PG? They just want to know a live example which you have conducted in during your ICT PG studies.
In ICT, we have MSc course. We always have MSc course. We have research proposals in that. So most of my MSc students have published publications in good journal. Because what I do, these postgraduate students are directly attached to the PhD students. And we develop a problem for MSc level students, and PhD students train them in such a way that they develop a research project, and you can see lots of publication from MSc students are coming up from my lab.
Right. So the last question is actually you have already answered in your presentation, but since this question has arisen, it is my duty to ask. The question is from Dr. Prakash Vag. Which are the different parameters of funding agencies to provide funds?
Funding agencies, first of all, they look into many parameters. For example, I should say that they look into your institute where you work. They look into your CV, whether you can able to implement the project which you have given. And second point, under that particular scheme, whatever funding they have available, because right now competition is too high for getting the funding, and these parameters plays an important role there, government funding agency. But my personal opinion is that we should not look more into government. We should move towards industry. In ICT, we are quite often doing this. We are developing industrial problems, and industry supports many of these problems.
Right. So I would conclude the question and answer sessions now, and over to you, Anju ma'am.
Very good afternoon, one and all. Am I audible?
Yes, ma'am, you are audible. Kindly keep your mic near to your.
Very good afternoon, one and all.
Ma'am, the voice is low. Be a bit louder, ma'am.
Very good afternoon, one. Audible now?
No, ma'am, it is not yet audible.
Ma'am, you're on a mute mode.
No, no, I
No,
am
she is.
unmuted.
Yes, ma'am, now it's
Am
fine.
I?
You can continue.
Okay, okay. Yes, yes. Okay. Okay. Sorry for the interruption. A very good afternoon, one and all. It's my privilege to propose the vote of thanks on behalf of KLE Society's College of Science and Commerce, Kalamboli. I would like to express my gratitude to Professor B.M. Bhanage, who has spared his precious time for us and graced this webinar with his presence. He has been a guiding source for getting the important information regarding research for students as well as for faculty members. To develop the quality, he also highlighted in his session, to develop the quality of the students, we should guide our student to become research oriented and to make use of new technology. He also motivated our faculty members to initiate our research work during their academic work. During their academic work, which would be helpful which should be helpful for our society. He has also highlighted many research-oriented schemes for student as well as for the faculty members. He also suggested to develop the link of research initiatives between faculty members to PG student and PG student to UG student to develop research environment. I would sincerely thanks to our enthusiastic management and special thanks to our principal sir Dr. G.D. Giri for his vision, commitment to work and its execution as well as for his motivation. I would also like to thanks to our science coordinator Dr. Prakash Badani for his encouragement. Commerce coordinator Mr. Yogendra Darvi sir, Junior College Coordinator Mrs. Swati Yevle, and my HOD Dr. Richa Singh. I would also like to give thanks to our organizing members, Mr. Yogesh Rane sir, Dr. Neelam Pachpute, and Dr. Kumodini Ahir, as well as all the faculty members, students who participated in this national webinar and spent their valuable time with us. Also, I would like to appreciate the efforts taken by our technical team, Ms. Neha Pandare and Mr. Prashik Tare, who made this occasion live by doing arrangement for this webinar. Thank you once again to all the participants who have attended this webinar. Last, very important announcement regarding feedback. The feedback link will be displayed on the chat box of the YouTube link as well as it will be shared on Telegram. It will be open for 2 hours. Thank you once again to all of you, those who participated in this webinar. Stay home, stay safe. Thank you once again.
And also to you, your head of the department, Dr. Richa Singh, your principal, Dr. J.D. Giri, and all organizing committee for inviting me to deliver my talk. Whatever thoughts I had just expressed. That's all. Nothing more. Thank you very much.
Yes, sir.
Thank you
Actually,
very much, sir.
Thank you, sir.
community is always plays an amazing role for motivating student like us, sir. Thank you so much, sir. And
Thanks a lot, sir.
yes, sir. Yes,
Thank
sir.
you.
You want to conclude with something?